Alright, so today I watched the video most US college students cannot solve this basic math problem, the working together riddle from Mind Your Decisions, August 13th, 2017. Basically, the problem is, actually, let me just remove this because it's going to be in the way. Alice and Bob can do a task in 2 hours. Uh, Actually, I'm going to do this, huh? And then we're going to say Charlie and Bob, and finally Alice and yeah, Charil and Charlie, and we're going to put a capital B here just for there we go. So this is going to be 3 and 4. So this is basically the riddle. Um, how long would it take to complete the task if they all worked together? Assuming a constant rate of completing the task. So let's do let's do t a plus b equals 2, t b plus c equals 3, and finally t a plus c equals 4. So these are our equations. What we want is t a plus b plus c equals, and we don't know. So to solve this, you have to first realize what does it mean for Alice and Bob to complete a task in 2 hours. You don't know the speed Alice works out and the speed Bob works out, and there's obviously many combinations. You can imagine Bob does nothing and Alice does all the work in 2 hours, so Bob's work time would be infinite to complete the job. You would essentially have a speed of 0, and Alice could do all the job in 2 hours by herself, and then when they team up, it's the same. Or it could be the opposite. Alice does nothing and Bob does it in 2 hours. Or it could be Alice and Bob can both do it in 4 hours, and when they team up, they do it twice as fast because they have the same, they work at the same rate, so it would be twice as fast. And when they team up with both 4 hours, they do it in 2 hours. And that's kind of intuitive. And now how does that work? You have to try to come up with a formula that works with this. And the formula is actually 1 divided by 1 over a plus 1 over b. Um, let's just try to put in numbers into this and see what it does. A equals 1, b equals 2. This is the time it takes. And I'm going to say this is going to be f. Let's say f equals, this is going to be like our function. I guess I could put f a b or something like this, and it would be equal to 1 over a plus 1 over b, and then you'd have, let's just say f equals, well, I guess it would be f of 1 and 2 equals 1 over 1 plus 1, oh wow, I meant to type 0.5 or 1 half and I typed 1 over 5, and what you get, that is actually equal to 2/3. Um, Basically, if you want to, you can write this as 2 over 2 plus 1 over 2, which is 3/3, 3 halves, what am I saying? And 1 over 3 halves is 2/3. So does that make sense? One person does it in 1 hour, the other person does it in 2 hours, they team up, they do it in 40 minutes. Well, it seems to make sense, and you can clearly see that if you plug in the same number, the number is going to be halved. It's going to be 1 over 2 over the number, and 1 over 2 over something is the number over 2. So it's actually going to be halved. We can try different values. I can put b equals 3, put a 3 here, put a 3 here, and then we get 3/3 plus 1/3, that's going to be 4. That's going to be 3 over 4. They're going to do it in 45 minutes if it takes someone 3 hours and he teams up with someone who can do it in 1 hour. You can see this pretty easily by saying, well, what if this guy works at his full pace for 45 minutes, and this guy works at a third of his pace for 45 minutes too? If this guy does 45 minutes work, this guy's going to do 15 minutes work, and it adds up to 1 hour. And the work was, where was I going with this? The 1 hour is because this guy would do it in 1 hour, and this guy would do it at a third of the speed. So yeah, basically what we can then do with this is write 1 over a plus 1 over b equals 2. We can also write 1 over b plus 1 over c equals 3, and then 1 over a plus 1 over c equals 4. Now we can start thinking about what our answer should look like. Obviously, it's going to be faster than 2 hours, right? Because if Charlie didn't help, it would take 2 hours, but Charlie's helping. So it's going to be faster than 2 hours. Now we can ask ourselves, who here works the fastest? Basically, you can compare the equations right here and see, well, here there's an A, here there's an A, here there's a 2, here there's a 4, and the only difference is the B and the C. And it takes longer with the C, so we can say that the C is actually working slower than B. Then we can say there's a C and there's a C, there's a 4 and there's a 3, there's an A and there's a B. The B works faster than A. And then we can do B, B, 2, 3, and then C and A. So A actually works faster than C. So then we can know that B is smaller than A, which is smaller than C. You can pause and think about it if you want. And since we know that Charlie actually works the slowest, which makes sense because he's in the two groups that work the slowest, and A is like 1 and 3 and B is in the 2 that work the fastest, this order really makes sense. And then you can ask yourself, well, we found an upper limit, which is 2 hours. Is there a lower limit? Well, imagine they all worked at the same pace. They would complete the work in 2/3 of the time they would do it with 2 people if they were 3. This is quite obvious because if 3 people work at the same pace and you remove one of them, it's going to be 50% longer. Add them back, it's going to be, well, I guess you could say 50% or 1/3 faster depending on how you see it. So yeah, that would be the limit. We don't exactly know the ratios, but we know that if they were equal, it would be 2/3 of the time. So we can do t a plus b plus c. Just going to copy this. We're going to put 4/3 of an hour is smaller. So our time is bigger than 4/3, but it is smaller than 2 hours. You can think about this again if you're not sure, but it's just logic and it doesn't really matter. It's just to verify that your answer makes sense, because it's quite easy when you're solving a riddle to come up with an answer and be quite sure you have the right one, and then when you think about it, it makes no fucking sense. So yeah, just making sure. We can then think about what it means to have the time of A, B, and C. It would be like plugging 3 numbers in this 2-number function, right? So let's try it. I'm going to copy this. Yeah, I knew it would copy with the space. I guess it's fine. We're going to put even one more. Plus 1 over C. We're going to put A equals 1, B equals 2, and C equals 3. And then we're going to do this. F of A, B, C. Actually, we're going to put 1, 2, 3. 1, 2, 3. That's going to be 1 over 1 plus 1 over 2 plus 1 over 3. And that's going to be equal to, let's see, that's 6/6 plus 3/6 plus 2/6. So 11/6. So 1 divided by 11 over 6 equals 6 over 11. So if they worked together at this pace, it would take them 6/11 of an hour. Now this number might seem to come out of nowhere, but again, think of A working for 6/11 of an hour, B working half of that, and C working a third of that. That's going to be 6/11 from A, 3/11 from B, and 2/11 from C. And those are going to add up to 11/11 of work. And if A worked alone 11/11 of an hour, he would complete the work in his 1 hour. So again, this makes sense. So we know that this formula makes sense, and if it's not really intuitive, well, I'm sorry, but I really thought it was. So it's the only reason I'm making this video. It's because something beautiful is going to come from this. Now that we have 1 over A, 1 over B, and 1 over C, and it's just 1 over this, you might be thinking, well, isn't there a way to solve this super easily? And there is. So basically what we have is t a plus b plus c equals this. I'm just going to, actually I'm going to leave this, it's fine. And we have here these values, so we can actually say, well, what if we sum this up, and then that would be wrong. But what we can do is take these equations and play with them a bit and make them more useful. So we're going to do 1 over on each side. So 1 over is going to cancel out. And here we're going to have 1 over 2. Here we're going to have 1 over 3. Here we're going to have 1 over 4. And these equations look really nice, don't they? They look amazing, honestly. 1 over A plus 1 over B equals 1/2. 1 over B plus 1 over C equals 1/3. And 1 over A plus 1 over C equals 1/4. This is so simple. And then we have 1 over T A plus B plus C equals 1 over A plus 1 over B plus 1 over C. And we have the values right here. We don't exactly have the values, but we know that if we sum all three of those up, we're going to have 2 times 1 over A. Actually, what am I saying? If we sum those three equations up, I'm just going to do it right here. 1 over A plus 1 over, 1 over B plus 1 over B plus 1 over C plus 1 over A plus 1 over C equals 1/2 plus 1/3 plus 1/4. These can be combined, so we're going to put a 2 here and remove this one. We're going to remove this 1A and put a 2 here. And we're going to remove this thing and put a 2 here. And then we have 2 over A, 2 over B, 2 over C. We're going to divide by 2 on each side, so 1, 1, 1. Here that's going to be 4, 6, and 8. And then we can know that this sum is equal to this. And now if you want to evaluate that, that's 2 times 2, 2 times 3, 2 times 2 times 2, so we have to do 2 times 2 times 2 times 3, which is going to be 24. That's going to be 6 over 24 plus 4 over 24 plus 3 over 24 equals 13 over 24, and that's 1 over t. So we can have t, a plus b plus c, equals 24 over 13. And that is actually the result. And I think this solution right here, this step, where you take these equations, flip them around, take this equation, flip it around, and just plug these equations into it, you don't even get the values for A, B, and C, but you get the final result. That completely amazed me. I just had to make a video about it. So yeah, this is it.